Hello, dear learners. Today I welcome you for lesson 3 of chapter 2, that is kinematics. Here is the contact information. If you face any difficulty in this lesson, you can contact me. Learning outcomes of today's lesson are: you should be able to state acceleration and deceleration. You should be able to distinguish between uniform and non-uniform acceleration. You should be able to calculate the value of acceleration using this mathematical relationship, that is change in velocity divided by time taken. So the contents which I am going to cover in today's lesson are acceleration, deceleration, uniform acceleration and non-uniform acceleration. Acceleration. So before stating the statement of acceleration, I will say one statement, that is, when you think of acceleration, you probably think of something speeding up. In our daily life, when we say that he is increasing the speed of the car, or he is running fast, or he started walking fastly, it means we say that he is speeding up, and speeding up means that acceleration. So acceleration also has direction, just as velocity. So if you see the statement of acceleration, acceleration is the rate of change of velocity. Change of velocity. In previous lesson we have discussed velocity. Velocity is nothing but speed with some direction. Speed with some direction, or you can say a car moving with some speed in particular direction. So here we are going to talk about change of velocity. Change of velocity, when we say change of velocity, means that we will take some difference of velocities. Change means from one point to another point, what was the change of velocity that we are going to take, and rate of change with respect to time means with respect to time we are going to calculate it, that will be acceleration. If you see here, rate of change of velocity is written here. Acceleration is equal to change in velocity divided by time taken. So velocity is changing, might be possible velocity is decreasing, might be possible velocity is increasing. So simply saying this thing, that speeding up, it does not mean that only when we are speeding up it means that we are accelerating. No, if speed is decreasing, even then there is acceleration. We will see in upcoming slide that when speed is decreasing, what type of acceleration it is. And if speed is not increasing or decreasing, we are moving with constant speed, but direction is changing, then we have acceleration also at that time. So here we are talking about in acceleration, we are talking about direction, so it is a vector quantity. Its SI unit is meter per second, or we can say meter per second square. How it is meter per second square? You know that in numerator we have change in velocity, and velocity has SI unit meter per second, and in denominator we have time, and time is measured in seconds. If we talk about SI unit of time, it is second. So in numerator we have meter per second, and in denominator we have second. The second of numerator, when comes downside, the second of that and the second of time are going to be multiplied. That's why it is second square. So when we take it again towards numerator, it will become meter per second square. In other words, if you see, acceleration occurs when an object changes its speed or its direction. Either the object is changing its speed, we have acceleration. If not changing the speed but changing the direction, even then we have acceleration. Or you can say if both. speed is changing and direction is changing, we have acceleration. If you see here in this picture, a person is running, he will change its speed. It will not, the person will not run continuously with constant speed. So when the person is changing its speed, acceleration is still there. If the person is changing its direction, acceleration is still there. So both change in speed or in direction, if they are occurring, acceleration is there. If either one of this is occurring, acceleration is still there. So let's talk about this example. The speed of the horses in this carousel is constant. If you see, the horses are moving with constant speed. Their speed is constant in this event, but the horses are accelerating. Horses are accelerating because their direction is changing constantly. If you see, this horse is having this direction and this direction is towards west. When this horse will come somewhere here, the direction will not be west, it will be between west and south. Similarly, if this horse will come somewhere here, the direction will be now south one. So direction is continuously changing. So acceleration is there. So again I repeat the statement that but the horses are accelerating because their direction is changing constantly. Constantly they are changing their direction. So there is acceleration. Hope so it is clear to you. Deceleration. Deceleration, or you can say retardation. In this scenario, when the velocity of an object decreases with respect to time. In previous slide, I have said that it does not mean that when the object is speeding up, only at that time acceleration will occur. No. If the speed or the velocity is decreasing, acceleration is still changing there, but we call that acceleration as deceleration. When the velocity of an object is decreasing, acceleration is there, but we call that acceleration as deceleration, or you can say retardation. Now let's see the example. When we are using brake during driving, what happens? We reduce the speed, we decrease the speed. We are taking benefits of deceleration to reduce the speed of the vehicle. So deceleration is useful when we apply the brake while driving, because we have to stop the vehicle, we have to reduce the speed of the vehicle. Therefore, there is acceleration, but when velocity increases or decreases with respect to time. So if you see here, what happens if you are driving a vehicle and you are near to the signal, but suddenly what happens, the light changes from green to red, then what will happen? You have to apply the brakes. When you are applying the brake, your car speed is going to decrease, then there is deceleration. Or you can say you are standing at signal, when this red light turns to green, you will accelerate your car. When you say accelerate your car, means you are increasing the speed, you are increasing the velocity, or there will be velocity, and that is known as acceleration. So hope so this statement is clear that there is acceleration when velocity increases or decreases, but when velocity is decreasing, we name it as deceleration or retardation. So now we are going to discuss about uniform and non-uniform acceleration. So before defining uniform acceleration and non-uniform acceleration, I will discuss about uniform and non-uniform. The meaning of uniform is constant. there is no change. Whereas of non-uniform, it means that there is some change, it is not constant. So uniform acceleration is a constant rate of change of velocity, means that velocity is changing but there is a constant change with respect to time. It is known as uniform acceleration. If you see this table, at time 0 seconds velocity is 0 meter per second. After 1 second time, velocity is 4 meter per second. After another 1 second, when it is time 2 seconds, velocity is 8 meter per second. So if you take the difference of first one and the second one, there is a difference of 4. If you take the difference of the second and the third one, there is a difference of 4. So this difference of 4 is indicating that velocity is increasing here but constantly. So uniform acceleration is occurring here, or you can say constant acceleration is occurring. If you see, accelerating objects are changing their velocity. They are changing their velocity. Initially it was 0 meter per second, then 4 meter per second, 8 meter per second. After every 1 second, speed is changing but constantly. So this is known as uniform acceleration. If we come towards non-uniform acceleration, it is opposite to uniform acceleration. How it is opposite? If the change of velocity for every unit of time, for every second, for every particular time is not the same, for every unit of time is not the same, then object undergoes non-uniform acceleration. If you come towards this table, you can see at time 0 seconds velocity is 0 meter per second, at time 1 seconds velocity is 1 meter per second, and after 2 seconds time velocity is 4 meter per second. Now see here, if you take the difference, initially 0, after 1 second there is a difference of 1, and after another interval, if you see 1 meter per second and between 4 meters per second, there is a difference of 3. There was a difference of 1 meter per second, then there is a difference of velocity, that is 3 meter per second. If you take one more time, that is 3 second, the velocity at that time was 5. Again, if you take the difference with previous value, there is a difference of 1. Again, if you see, here is the difference of 2. So continuously there is a change in velocity. Here it was 1 meter per second difference, here 3, then again 1, then again it was, next time it was 2. So it is not uniform. Constantly there is a change in velocity. So we call such scenario as non-constant acceleration. Non-constant acceleration, or you can say non-uniform acceleration. Here are some examples related to uniform and non-uniform examples. Non-uniform accelerations. Example of uniform acceleration. Uniform acceleration. When we drop a ball from some height, ball falling from a height, it will continuously move with constant speed, or you can say with constant velocity, so it will be a uniform acceleration. Similarly, cycle moving down the slope when rider is not pedaling, this is also uniform acceleration. Child coming down from a slide, it is a uniform acceleration. Now, if we see examples of non-uniform acceleration, car moving in the crowded street, continuously brakes are going to be applied. So sometimes we have to increase the speed. So it is not the uniform velocity there. Velocity is continuously changing and it will be different. So we say it non-uniform acceleration. motion of train from platform onwards. It is also non-uniform acceleration. Cycling in the hilly area is an example of non-uniform acceleration. So here is the question. Suppose a jet airline starts at rest at the end of a runway and reaches a speed of meter per second. So now see here, jet airliner starts at rest, and you know at rest we are having no motion, we are at still position. So what will be the velocity? It will be zero. So I say that vi, initial velocity, that is of rest, that is 0 meter per second, and at the end of a runway and reaches a speed of 80 meter per second, I name this speed or velocity as vf, final velocity, or which is equal to 80 meter per second. In 20 second time is given, you can calculate change in velocity. Time is given to you, simply vf minus vi, you can say v2 minus v1 as well. So vf was 80 meter per second minus initial velocity divided by time, so answer is 4 meter per second square. This is your acceleration. Hope so it is clear to you. Here are some practice questions. Question 1. Calculate the acceleration of Josh riding his bicycle in a straight line that speeds up from 4 meter per second to 6 meter per second in 5 seconds. So here if you see, 4 meter per second is the speed, that is initial velocity you can say, and 6 meter per second will be your final velocity. You can calculate change in velocity here. Time is given to you. Simply apply the mathematical formula of acceleration and you can calculate acceleration of Josh riding his bicycle. Now question 2 is, Cody's car accelerates from 0 meter per second to 45 meter per second to northward in 15 seconds. Time is given. Again you can see initial velocity is given, final is given, you can calculate acceleration. Dean is slowing down. Question 3, very important question. Dean is slowing down on his skateboards. If you see, slowing down means velocity is decreasing. So which acceleration is there, but we name it as deceleration. So he starts at a speed of vi, you can say initial velocity, that is 5.5 meter per second, and slows down to 1.0 meter per second. This will be the final velocity over a time of 3 seconds. What is Dean's acceleration? So it is acceleration, but we name it deceleration because if you see, vf is this, vi is this, if you take the difference of this, or I can say that if you calculate change in velocity, it will be negative. Then when you divide that change in velocity with time, you will be having acceleration, which will be having negative sign, and when there is negative sign, it represents that there is deceleration because Dean is slowing down on his skateboard. Hope so it is clear about the questions, that what is asked by you from these questions. Thank you so much. If you have any question, do let me know, and do not forget to subscribe and hit the like button of YouTube.